Welcome to Atmosoft TED Talks, a live show where we discuss everything you need to know about software development and technology in business. I'm Natasha, your host, and joining me today is our COO, Bill, a solutions architect at Atmosoft. Hi, Bill. Thank you for joining us today.
Hey, thank you for having me again.
Yeah. So today we will be talking about our code review template that we are giving out for free on our page. So let's just dive into it. Are you ready to talk about it, Bill?
Yeah, absolutely.
Cool. I need to turn this on. There we go.
Yeah.
Okay.
All right. So first thing we'll go over for those of you who are new, what a code review is. So, well, one of the ideas that's actually this has been around for a while, but it wasn't initially kind of done, but we found this pattern where we're able to have better production level code if the code goes through a review process. And what the code review process basically is, we're looking to make sure that the code follows any coding standards that a company has in regards to deployed code. Make sure there's no identifiable logic bugs. You know, those you don't catch those all the time, but a lot of times you'll see some code and you'll be like, hey, I don't really understand what's going on here. Why are you doing this particular way? Or you're looping over these variables and you actually do this loop twice in different sections. So just having someone else, it's basically like proofreading. Like if you're going to send out a business email, or if you're emailing, the executives in your organization and stuff like that, sometimes you'll want to make sure that you're getting the right message and everything across. And so you run it by a coworker and say, hey, what do you think about this email that I'm about to send to management? Whatever. Code review is kind of a similar process. We're going to sit down and we're going to talk through your code, and then you're going to explain it, and then we're going to have a dialogue about it. And I may offer some suggestions, I may not offer any suggestions. The code may be fine, and we just say, okay, we're good. And this document that we're about to go over is just kind of a general checklist for items that we look for when we're doing code reviews out in the field and internal to our organization. So we can go ahead and get started. So these are the main areas that we like to check. I'll talk about each one of them individually. Functionality. Okay, one of the key things you want to bring into your code review is going to be, what feature, what use case, what bug, what were you working on, and what was what were the inputs, like what were you supposed to do, and then basically how he did it. I always use this period to kind of give an overview of the task that I was assigned, and then briefly talk about the implementation. And when I say talk about the implementation, I'm talking more about the code structure and then the pieces of the code that I touched and modified to implement this new feature, to fix this bug, or that kind of thing. So here we're looking to see that if there's anything, like, just you're looking at the code, you're talking about it, and as the code reviewer, you're reviewing the code and you're looking to see if anything immediately jumps out at you, like a logic bug, or maybe there's some work inside of a function and it's kind of unclear on the intention, and there's no comments around that. So what we're looking for here is to make sure that the core functionality of the code is behaving as expected. And this is where you're going to introduce, as the person whose code is getting reviewed, you're going to say, I was working on task one. Task one was a feature to add a checkout button to the web page, and then here were the requirements for the checkout feature, and then here's the code that I implemented to do that checkout feature. And then this also gives you a chance to double check your work too, right? Like, that's another important process. The code reviews, make sure you got everything. Like, if you can't, if you have a feature and there's 10 tasks associated with the feature, and maybe you only got 9 of them done, and you kind of forgot or didn't do the 10th one for whatever reason, you can catch a lot of that there. So the first part of the meeting should definitely be a review. This is what I did. Here's how my code is structured. These are the code files that I touched, and here's how it's supposed to work. And then here is what the user acceptance testing is supposed to be. And then you could even include in this portion of it, it's not everybody does this, but you could even do like just a brief demo. Like, I'm going to just walk you through the web page. We're going to log in. we're going to add some items to the cart, and we're going to check out. Simple example there. And so this is kind of the introduction where you're going to discuss what you did and why you did it, and then later on we go into the other sections where we actually start diving into the code. So the next section is the code structure and organization. Now, a lot of organizations and products will have a specific subject or a specific structure. Okay, so the way I like to do my projects is kind of keep everything using the layered architecture. Keep my APIs over here, keep my services over here, keep my UI over here, and maybe you're doing work across all three, right? So you just want to show how you're maintaining the existing structure. If you have a separate DLL that you're putting all your services in, the service you created for the shopping cart, there's a shopping cart service. A lot of newer frameworks, especially in the .NET world, are getting not big into recently. It's been going on for a while, but it's a lot easier to do something called dependency injection. And so you want to make sure, hey, I have an interface defined for my service so that it can be injected everywhere else in the code. And I'm following all the existing structures. And you want to have the conversation anytime you made a choice to make some sort of deviation, to make sure that you're keeping in communication with the team, and the code reviewer is aware that, oh, I did create a service, but maybe for some reason I put it in the modules directory or something like that. Anything where you're breaking a standard, and it's okay to do that as long as you have a logical reason for that, right? So you want to try to stay within the existing code structure, but that doesn't mean that you can't make changes to kind of help the way your particular feature is implemented, but you try to stay in that. And here's where you're going to outline, okay, I added this web page, I added this component, I added this service, I added these functions to the repository layer, and you're just going to go through, and then your job as the reviewer is to check and make sure that the code is structured and falls in line with the predefined agreements that the team has set for what your coding standards are. So these two, the first one's kind of your introduction. The second one is I'm showing you the structure of my code and where all my individual pieces are. And your job here is to make sure that you're following the structure, and that your code is basically following your standards. You see in the template it says, are the functions and the classes relatively small? We're trying to make sure that we're adhering to the single responsibility principle. A function and class and a method, they all do one specific thing. So if I have a cart service that for some reason is also writing out an invoice, that's not going to be good design, right? Because we're mixing an invoicing code with the shopping cart code. The way to do that correctly would be, I have my shopping cart code over here, and I also have this invoicing code, and now I'm just going to inject using dependency injection into the shopping cart class the pieces that it needs to do the invoicing, but invoicing is separate from the shopping cart. Shopping cart can consume invoice, but it shouldn't ever be doing anything directly with entities owned by that particular service. So you can kind of think of your database tables and stuff. I think about it as being owned by particular service objects, which in reality are classes, but we call them services. So but yeah, so your code is structured well. And you explain where you put all your code. You talk about any deviations and the reason why you made those deviations. And then you're looking at the overall code and kind of making sure that everything is, I'm not in a method and then I'm calculating a bunch of invoicing pieces, and the code is called, calculate shipping amount. And then in that, have code in there that's figuring out what the invoice is going to look like. It's going to get sent to the customer. That's not the appropriate place for that. And you want to make sure that your code is well organized and well structured. The next section is the readability and maintainability. What we're looking for here is, can I look at your code and can I go through it and can I easily understand what you're doing? And as the reviewee, not the reviewer, it's the reviewee, what you want to highlight here is especially want to draw attention to anywhere where you're doing some, I'm not going to call them questionable things, but you're breaking, like, if I looked at this code, I don't immediately understand what it's doing. And at a minimum, if you're doing stuff like that, it should have a comment explaining why you made this choice. I had to do this particular thing for reason XYZ. This was faster. I need to perform the read-write performance. And so we went with this optimized method here. or something. There should be a note in the code that's outlining why the code is more difficult to read. Because one of the things that happens with legacy systems a lot is people leave and people forget, and then all of a sudden you have this area of your system that no one will touch. I'm not going to touch invoicing because I don't want to break it, and it's working 90% okay, and I don't want to make the problem worse, and we want to avoid scenarios like that. And the way we do that is when we get deep into the code, we want to be leaving notes both to our future selves and to other people that may come after us for maintainability, like, oh, this flag is set because XYZ, and you should never change the value of this flag, different things like that. And anytime where I think every developer could appreciate it when I say anytime you're doing something non-standard in the code, right? Most code is I'm looking up data, I'm comparing some values, and then I'm making some decisions, branching or I'm looping over a bunch of records, and I'm summing some stuff up, like all that stuff, standard stuff. It's when you start going into the weird, not the weird, you start going into the more complex code where it might need some explanation on why am I using 2 for loops and I'm incrementing with an integer value, and I'm addressing 2 different columns, and I've nested for loops. That code's fairly complicated and probably should be explained before it. So what we're looking for here is comments and help where we, as the reviewer, we're looking for areas in the code where maybe the direct code intention is not cleared, it's not commented correctly, maybe the function's doing more things than it should, maybe you see a function again where we're supposed to be doing something in the shopping cart service, but we're actually calculating up invoice line items, and that's not really appropriate to be in the shopping cart. Maybe something the shopping cart needs, but we have a whole a modular invoicing subsystem that we shouldn't be bypassing and working with invoicing data directly. So you're looking for deviations like that so that you can keep the code standard and keep it maintainable and keep it upgradable. Next one, error handling and exception cases. So these are going to be exception cases, also like any of your edge cases, any area where, error handling in and of itself is expensive. And so you will, when you're writing .NET, I got to be careful here because I don't want to give people the wrong impression. I'm not saying never do error handling, but if your code is generally running fine, wrapping everything in a try catch exception block is completely it's kind of pointless, right? Because you're not going to do anything if you get a generic exception. If I just get a general exception that's been bubbled up from somewhere, I'm not going to do anything. The type of exception handling that you want to look for is, I tried to call this service and the service is offline, so I got a 500 HTTP response when I tried to call the API. That type of error handling is fine because maybe you want to add some circuit breaker or some retry logic in there, and you can try to test and see if you can hit the service again. There's some good software patterns around that, but in general, we want to try to avoid having any just broad exception catching, right? We want those to bubble up in testing so that we could see, like, okay, we have a bug where we were using recursion and we forgot to put the statement that causes the recursive loop to stop, and so we just recurse for infinity, and eventually we run out of memory, right? And so we want to see those particular errors because those represent logic flaws. Whereas there are certain errors that we do want to catch because maybe we want to retry again, or we want to take some other action, or we want to kind of get into logging. And then here's also too where you can explain some of the code around possible edge cases that you came up with. Edge cases are challenging to handle from the aspect of sometimes everything costs money. Everything boils down to somebody's paying you to do the work, and maybe there is this edge case where maybe 1/100% of the users are ever going to get into this particular edge case, and it would take you 20 hours to implement the solution around this particular edge case. You got to be careful about your edge cases, but here's where you also want to specify them. I coded in this logic where I'm doing my validation over here. And if this value is set a certain way, I know it's going to cause problems later on down the code. So I added this exception that gets thrown when, the dealer ID is not passed in, or the warranty number is not in the right format, or something like this. Here's where you want to kind of specialize and kind of outline on those. So let's go to the next page. All right. So here we talk about what we'll talk about. Here's your testing scenario. Now, testing scenarios go in two different flavors. I think the industry as a whole right now is not really in a flux state, but there's definitely some crossover. Now, there are different types of testing. When you're doing a code review, specifically, we're most likely going to be looking at we're going to be looking at unit tests. Now, unit tests are made, they're also code artifacts, and they're made to test particular functions of your code to make sure that particular function behaves the way it's supposed to. So here we're going to review the unit test code, and we're not going to be obsessed about code coverage. Code coverage is an important metric, but it is not the end all be all of metrics. So if your goal is to get to 100% test coverage, you are wasting money. There are some things that don't need to be tested. And we want to make sure that on these unit tests that we're following any of the coding standards that have been set aside, that we're using the same framework that everyone else that's doing unit tests is using. You can, but you really don't want to mix like X unit tests and MS tests kind of unit tests. You really should have a consistent framework on the team where the team's gotten together and said, most people use X unit, or not most people, a lot. And so the team decides that we're going to use X unit. MS test is perfectly viable option as well. They all kind of do similar things with just different attributes that you put around your classes. So we're going to look and make sure, we're testing the right things and that our tests aren't fragile. Fragile means that if I'm testing the input if I'm testing the functionality of a function and I slightly change something internal to that function in your test break, you have a brittle test. You need to be testing in when I pass in these inputs, I'm getting in this output, or this flag is getting set, or these things are getting done. We're not trying to test the internals of the code. We're trying to test the code as it would be consumed by other objects. So here we're testing to make sure that we're kind of following all of those standards. And then as we spoke of last week, we have a security checklist, and I think it's a little bit more important, and maybe we should expand this document out a little bit and kind of list out some of the that 10 WASP thing that we posted about last week. Maybe we include those in here, like make sure you're doing, you have your sanity checks, you're doing your validations. I do sanity checks all the time in my code. You'll see comments like sanity check, and I'm just making sure that everything is exactly values in ranges of values that I expect them to be, and I'm not getting anything crazy and then trying to process that through the rest of the code. Are we doing validation? Are we validating our inputs? Are we validating our outputs? And are we consistent in what we're checking for? And are we at least aware of and kind of coding around some common security problems that can appear in our code? Like did our code did we take active consideration of security considerations coming in with this code block? Performance and efficiency, we included this one in the documentation, but again, this actually may not be an issue. My thing is on performance especially is try to avoid premature optimization. That can lead you down a path where you're spending, a week trying to get this code to be under a millisecond or under a second or something like that, and you're working on this one function because you think that is where the problem is, and then you get that function, it's tweaked as much as you possibly can, and you reduced it by like maybe 10 milliseconds or 15 milliseconds because you weren't actually focused on the actual area where you need to do the performance optimization. So anytime you're doing performance, obviously we're looking at the code and reviewing it to make sure that we're not looping unnecessarily, that our general code structure is fast. We're not doing 5,000 deep if statements, if this, if this, if this, if this, there's better ways, better patterns to do that, that our functions are broken up and that they're small and they're atomic. We're also checking for that above. But here we're looking to see if there's any places where we could just quickly eyeball and say, oh, you know what, this might be a little bit faster if we do this. Anytime we can save is good. But this is not the place where you're diving into and you're actually going to make hardcore code changes to performance. So you look at performance when a performance red flag comes up. This page is taking 90 seconds to load. I want it in under 5 seconds is a reasonable time. So we want to get that load time down below 5 seconds. Where's the code the slowest? The code is, we benchmarked it. We know the code is slow here, so we're going to go in and we're going to optimize this. Maybe we're going to change it. We're going to create a view in the database or optimize the query with some indexing. A lot of times it may not even be related to your code. It just may be slow on the database side, or it could be slow on the network side. And so when you get into performance and efficiency, this isn't the place where we're doing that. What we're looking for here is any obvious performance or efficiency problems. And then at the end of the code review, I think it's also relevant to have a section where you say, did you update the documentation or any relevant documentation, right? Did we document this particular feature and our architecture of this feature? Okay, so just the overall architecture. It doesn't have to be something that takes you 3 days to write this detailed explanation of the code. That's not what we're looking for here. We're looking for a high-level overview of your feature. What are the components and pieces involved? What new pieces did you add? Did you update the system architecture to reflect any changes of the way that the code evolved and that kind of thing? So that's what we're looking for here. And that's I think one of the last things we do. I think we got one more page.
Yeah, one more page with just two more sections.
Yep. And here we go again. This one kind of flows throughout it. But here we're going to be checking to basically make sure that we follow any established, published coding standards and guidelines that we have. When you work in an organization, and as the organization grows, this becomes more critical. If you have a small one-team development shop, 2 to 5 developers, and you're all kind of working together, this isn't as important as if you have like 8 teams all running in parallel, doing different work. This becomes a much bigger deal and something you should definitely pay attention to. There's general coding standards out there for you to get started with. You could just go grab that document, say this is what we're going to do, and see how it works, and then start tweaking it for your organization. But coding standards should definitely be in place. It gets a lot harder to read code when one developer is using camel case, the other guy's using Pascal case, and we're switching back and forth, and sometimes they're using underscores, sometimes there's no underscores, sometimes function names are like this long, sometimes they're like this long. You really want to kind of find what fits best with your organization, and this is open for interpretation. There's no right or wrong way to, or I guess there's a wrong way not doing it. You should definitely have some standards that you're following, and I try to implement depending on the organization, smaller or bigger standards as we go through. The version control and deployment, as soon as the code review is done, is typically when I say that. So there's different branching and source control strategies, and again, it's a pick for the organization, your team, whatever works best for you. I like the feature branching, although I've heard counter arguments to it that are completely valid. So at the end of this is when the reviewer is basically going to go in and, we do this at the pull request. So I worked on a feature, and then I'm ready to merge that into the main branch and get ready for it to be deployed to test. Or maybe the testing branch or however you have this set up. In our case, we have a very small team, so we just push into master or main, push into main, and then from main we push out to test, and then from there in this particular scenario, and then from there we go from do a push to production, right? And you can have a testing branch and a main branch, and you can work those however you want. In this particular scenario with a small team and super communicative, we just work more in the model of we're getting ready for a new production release. We'll take the feature, we'll merge it into main, and then we do it from there. So at the end of this process, you're most likely going to be approving a pull request. I know Azure DevOps gives you a great little screen where you get a pull request and you can go in and you can look at it and you can check all the files that were modified and you can look at all the code. So we kind of use that in our review process, and then you're going to approve, and then it's going to merge into master. And then hopefully you have automated deployments set up so it just kind of flows out to test after that point. But at the end of this is where you're basically going to approve or deny the pull request based on your conversation. And then we added a little section for notes. So if you have any notes or comments, and it's okay, like there is no failing in a code review, right? There can be suggestions. You forgot about this particular, this particular code rule that we have, and so just go back and fix your code so that we're following the coding standards and that kind of thing, and then you would basically cancel your pull request. You would go and do your fix and check it back in, and then you would do the second review. At that point would be a much shorter review depending on the list of possible issues you have, and using a code review is always a great idea. I highly recommend it, because sometimes we get code blind on code that we work in, right? And so you just now, I'm not saying you lose objectivity, but you just might not see something, and just having a second set or even a third set of eyes, just kind of take a look at it and just be like, yeah, that looks good. I've caught in so many bugs. And I've missed them too, but I've caught in a lot of bugs before they got into production by like, oh, why are we doing this here? This section of code doesn't make any sense. And then we look at it and we're sorting it out, and we're all like, oh yeah, so I misunderstood what we were supposed to do here. That's another thing that a code review is good for, is making sure you understood the requirements. Maybe someone else heard that feature discussed about, and when you read out your 10 tasks that you did to complete that feature, maybe they interpreted the original user story different. Maybe they interpreted what they heard from the PM different, maybe from the business owner. They didn't hear it the same way or process it the same way you did. And so at that point, you can go and get clarification and make sure that you got all that together. So that's how we do code reviews, and this is a high level overview of the various areas we hit and why, and then what you can do around pull requests and that kind of thing. I like that model a lot because it just shows you everything has changed. You can go through it real quick, you read the code and kind of get an understanding, and then they can explain to you, kind of what they were thinking, and it kind of gets you guys in sync too a little bit better with when you have to run into his code later and do some maintenance. You've already had some exposure to it and you kind of knew what his overall objective was. So that's a good thing. I highly recommend code reviews. And if you need help using code reviews, you can call us. We're glad to help you out. We can do one-off code reviews. Seriously, call me up. You can book an hour and we'll do a code review, and then we can be done. So if you need any help or want help in the process, you can give us a call and we can help you get that out. We are publishing this template today or tomorrow, and free download, and you can have at it and go ahead and use our template to start doing code reviews. Again, highly recommend them. They will help strengthen your software and improve team communication. There's a lot of benefits, and I don't see many drawbacks aside from time and cost, which it's going to cost a little bit extra because there's two people for a little bit of time. And typically a code review session shouldn't be more than 30 minutes. In my opinion. There'll be others that argue with me that you should, review if you have a mission critical system where a failure causes astronauts to get blown up in space, or someone's heart doesn't get monitored correctly and they die and no one's notified, that's a whole different code review process. And I'm not saying quickly review that code. I'm saying production ready to go. It should be a quick conversation, overview of the particular feature or whatever bug you were fixing, and maybe a little bit of a demo, and then some code discussion, and then you should be done, and that should be good. Now, again, mission critical systems, it's going to be a different process because there's people could get hurt if every single line of code is not 110% perfect. At that point, I would be like, okay, on line 1 we did, and then on line 2 we did, and then on line 3 we did. Yeah. So it's dependent. I don't want to just say blanket statement 30 minutes because some systems need to be reviewed under much more scrutiny than the standard average code that we deploy for business applications.
Yeah, and I personally think code reviews should be as common as having an editor come in and look over your book that you wrote. Like it should be a very common practice in the same way because it is so like essential. Like I feel like it's the same thing as when you write a book, sometimes you won't notice when like the continuity isn't there and you think it
Yeah,
makes sense going from plot A to plot B, but then someone else will be like, I don't really understand how we got there. And I feel like
yeah,
code reviews are kind of the same thing, but for code, and that's why they're essential,
yeah,
which
yeah.
is why
I
we
agree.
want to give out this free template. You'll be able to get it from our LinkedIn page, which is Atmosoft on LinkedIn. You can download it and then print it and then use it as many times as you need to.
Yep,
So,
yep, yep. We would love for you to download it and then also provide feedback. Maybe there's some things that you think we should consider in this template, and we can evolve this with community feedback and
mhm.
and get a better code review template. Maybe we missed something entirely. Maybe we're the way your organization does code reviews is 100% different than what I just was discussing. And we're interested in hearing that and seeing how other people are doing as well. This is how we do it internally, and this one has been working for us fairly well.
Yep. And also, hello, Amber. Thank you for chatting with us. I just wanted to say hello and shout her out. But other than that, do you have anything closing that you want to say before we end this?
No, that's it. That's it. Appreciate everyone's time, and I hope you enjoyed the video and found some value here. And always open to feedback. I think that's the
Yes.
most important. That's one of this things that this highlights is just everything is a feedback loop, right? If we all work together and we provide feedback and we can optimize and then we all end up in a better space. And that's part of what code reviews are about. Is here was my idea. Oh, here's the idea I have about your idea, and then we're communicating and we're iterating, and we're improving the overall system and the overall code, and we're also exposing other team members to our code. So I think that iterative optimization is a great way to do, and this document is definitely one of those.
Yes, for sure. And also, when we say that thing, all the things that we do here are a community effort. Like we really love to hear your feedback. So again, I would urge you if you have anything to say, any critique or anything else, just let us know. But
Yep.
other than that, we're going to close out. So that's it from us. Join us next time as we explore more tech topics in Tech Talk with Atmosoft. And remember to stay curious and stay integrated. And we're going to do our
Bye.
closing out graphic.
Yep.